There we go, it's back up. What type of variable is y? Is it discrete or is it continuous? So discrete means that it can only take on very specific values, like when we talk about number of children in your family. Continuous is something like your grade in a class or the percentage that you get on a test. What do we think? Would be continuous. Somebody could play for, 172.5 minutes. Or they can play for 172.2 minutes or 172.01 minutes. If somebody's got a good enough stopwatch, we can start and stop at any time here. So this would be continuous. Any value between 0 and 1,440 minutes, that'd be 24 hours, can be spent playing Minecraft each day. You can take any value, then it's continuous. If you can only take specific values, then it is discrete. What is the standard deviation of 42.7 telling us? What is the standard deviation of 42.7 telling us? What does standard deviation tell us? Standard deviation tell us here. That's exactly correct. Oh, wow. Okay, hold on. Let me see if I can get that to come up with everything else in the background. There we go. The amount of time spent playing Minecraft each day typically varies by 42.7 minutes from the mean of 150 minutes. Right. Part C, they wanted us to find the probability of y being less than or equal to 90. They gave us some important information up here at the top. They said that it was normally distributed. So once I know that something has been normally distributed, we can use everything that we learned way back in, I think it's chapter 1, maybe chapter 2, about normal distributions. Sorry, guys. I think that it does that automatically. Right. And we're going to interpret this value. So first we're going to find it, then we're going to interpret it. So I drew my normal distribution, like we did on our virtual day. I have the mean and the standard deviation next to this capital N drawn next to my normal distribution. I have to mark the mean, and then I went in and marked my standard deviations. For the AP exam, if you have it like this and you mark the mean in the center, that is considered good enough. You don't have to mark all 3 of those standard deviations along the bottom. I like to do that so that I know about where 90 falls. So 90 is going to be on the left side of the mean. We want to find this left tail probability. So if I grab my graphing calculator to find the probability that y is less than or equal to 90, I'm going to push second and vars, which will take me to normal CDF. Let's see if I can pull this up on my calculator here for you guys. We'll go through this. There we go. So second and vars, I want the option that says normal CDF, which is the second option here. Use my arrow to go down. I'm going to erase these. Do you guys see a screen like this, or did it just like put normal PDF up on your screen? All right, so I'm going to make mine look like yours. Mine's not gonna look exactly like yours, but I'm gonna go in and put those values in. So normal CDF. The first value that I want here is the lower bound. So I'm gonna put 0 because I wanna go all the way to the lowest possible percent, lowest possible percentile. So that's 0 since I want the left tail. Then right here, I want my upper bound. What's the highest I want this to go? 90. So I'm gonna put 90. And then I need a comma. Then I want the mean. What was our mean? 150. And a comma. And then I need the standard deviation. What was our standard deviation? 42.7. I'm going to close my parentheses. I'm going to hit enter. That value right there is giving me the area from 90 and to the left. That is the same thing as the probability. The area under that curve is 1 or 100%. So that's how I got my answer here. If you want to use the table way of doing it, you have to convert them to z-scores, and I've got that here. If you want to follow along with that, you're welcome to look up in the notes. We converted to z-scores and used tables back in chapter 1 or 2. Yes, ma'am. You will have your graphing calculator on the test, yeah. You'll also be given the table in addition to that formula sheet front and back. They give you the table front and back. Yes, ma'am. Yes, good question. If you use your calculator, you need to have the picture that's labeled. Again, you don't have to have every value along the bottom, but you have to have the mean. You have to have the n with the mean and the standard deviation. And you do have to write down what you typed into your calculator so they know that this number wasn't just something that you pulled out of thin air or saw on someone else's paper. Right? So very, very good question. If you're going to use the calculator, you do need this, and you do need to state what those numbers are. Your lower bound, your upper bound, mu, and sigma, mean and standard deviation. So you kind of don't get out of writing either way, it's just how much computation are you going to do by hand. If you do z-scores, you have to do the computation by hand, and then look it up on the table. If you use your calculator, you need to write down what you're putting into the calculator, what those values are, how you know they go, where they go. And then hit enter to get your probability. All right. Let's look at the last one here. Finding the probability that somebody plays in between 45 and 90 minutes. Go ahead and try this on your calculator. The lower bound would be 45. Upper bound stays the same. Your mean stays the same. Your standard deviation stays the same. Got my answer up on the screen, so once you have yours on your calculator, you can check yours against mine. Anybody have any questions for how to put this in your calculator to get this percentage back out? So get those probabilities. So again, you want to make sure that you have the picture. Things that have to be on the picture, you have to have it labeled with N and your mean and your standard deviation. You have to show your curve. You have to have the mean labeled. And you have to have the area that you're looking for labeled. You do not have to write down all the standard deviation values in there. You do not have to write down 3 standard deviations left and right. You need your sketch with what you're looking for. If you use the calculator, you need this, what function you use, what values you entered, what they mean. And LB and UB is fine, they understand that that means lower bound and upper bound. So those abbreviations are appropriate. Then I got 0.0730, I rounded up the calculator. So what that means is out of the population that this sample was taken, there is a 7.3 or 0.0730 probability of selecting a Minecraft player who only plays between 45 and 90 minutes a day. Like most people are about the 2.5 hour mark, 150 minutes is 2.5 hours. I know my daughter would love to play for that long or longer. My 6-year-old thinks Minecraft in the fun is the best thing ever. She's sick, she's celebrated and she doesn't like it when she works really hard to build something and then it gets destroyed. So she's just working on world building right now. All right, go ahead and flip the page for me. Don't forget 5.1 homework, sorry, not 5.1, 6.1 homework is due tonight. Those of you that weren't here yesterday, we drew daily wages. These were the probabilities that came up. There were only 15 people in the class yesterday, including me. One person drew $1 an hour, 2 people drew $5 an hour, 4 people drew $7 an hour, 7 drew $10 an hour, and 1 drew $15 an hour. Nobody drew the 25. And then we found our mean and our standard deviation. This was a weighted average. For how to find the standard deviation, if you were not in class yesterday, you'll want to go back and watch that video as a reminder for how to find the standard deviation, but this is a weighted standard deviation as well. So I want you to copy this onto your page. I believe it's page 7. For whatever reason, the page numbers didn't print on all of them towards the end of the packet, but not at the beginning. I don't know why. And then I want you guys to go through and do number 2. They give you about 4 or 5 minutes. We're going to add $10 to everybody's hourly wage. And I want to know how that affects the mean and how that affects the standard deviation. So add $10 to everybody's wage. Find the new weighted expected value, the new weighted mean, and find the standard deviation. The probabilities, by the way, stay exactly the same. All we're doing is changing their hourly wage. We're not changing who drew which part, so we're not changing the probability. Value, bias probability. All the way through. What would those new wages do? So one would be 11 and then 15, yes. Yep. So there's just this shift. If I were to see this graphically like a histogram, I would just see that entire histogram like take one giant step to the right. The whole thing moved. What would our new mean be? Or rather, how would I calculate it? What would I need to put into my calculator to calculate the new? I take the new wage, multiply it by the probability. So 11 times 1 over 15 plus 15 times 2 over 15 plus 17 times 4 over 15 plus 20 times 7 over 15 plus 25 times 1 over 15. And since nobody had this, I don't have to include that. There's can if you want to, but I know when I multiply something by 0, it's just going to be a 0. So I found the new mean to be 1826. It's just the old mean plus 20. Standard deviation, though, did not change. Standard deviation stayed exactly the same. How did adding a constant affect the mean and the standard deviation? How did adding a constant to each of our x values affect the mean? It increased by how much? By 10. So the mean is increased by $10. How was the standard deviation affected? It remained the same. Standard deviation stayed the same. What about if we double the weight? Instead of just adding 10, if we double them all, what would they change to? What would the new wages be if we double the original wages? Two, 10, 14, 20, 30, and 50. So we expanded this. What do you think is going to happen to the mean? Do you think it's going to increase, decrease, or stay the same? Increase. When we added 10, we saw that the mean increased by 10. If I'm doubling everything, how do you think the mean is going to increase? gonna double. Do you think the standard deviation is gonna change or stay the same? Change. Last time it didn't change, why not? We shifted it, so like my original histogram stayed like this, and it shifted on down. How far apart, like what was the range from what we did yesterday? From 1 to 25, what's that range? 24. What's the range of my new wages when I added 10? Still 24, my range didn't change, it didn't get any more spread out. Did this get more spread out, or did it stay the same? It got more spread out, so that absolutely will affect my standard deviation. How do you think it will affect the standard deviation? Double it. Look at just what happened to my range. You said it was 24 before, right? What's the range now? 48, which is double my old range, right? You guys are absolutely correct. My standard deviation doubles. My mean doubles from the original. How did that affect it? Both the mean and the standard deviation were multiplied by 2. So those of you that were here yesterday, which of these options, getting $10 more an hour than you did yesterday or doubling your original wage, which option would you rather go with if you were presented with this choice? You want $10 more? Does anybody want the doubling option, or does everybody want the 10 more option? I don't really care what happens online. Does anybody remember what I told you yesterday? I had a 10. Why don't I care? It's gonna go to $20 an hour either way. So yeah. If your old wage was 1, 5, or 7, you want option number 1. That was 7 people that were here yesterday. If your old wage was 10, it doesn't matter. If your old wage was 15 or 25, we didn't have anybody with 25. We did have one person with 15. They're going to benefit a lot more from doubling than from just adding $10 more. Choose the option that gives you the biggest wage increase. Once you're done copying this down, go ahead and flip your page over. We're going to talk about kind of our 2 big ideas for today. Fairly straightforward. Our big ideas is what happens when we add a constant or subtract. What happens when we multiply by a constant or divide. If I add or subtract, my shape stays exactly the same. The center will move by either adding or subtracting C. And the variability, the spread, things that sigma and my range and my IQR are describing, that stays exactly the same. If I'm multiplying or dividing by a constant, the overall shape still stays the same. If it was skewed left before, it's still going to be skewed left. If it was skewed right before, it's still going to be skewed right. If it was mostly symmetric, it's still going to be mostly symmetric. The center will move by multiplying or dividing my original center, my original mean, by whatever that new value is. And my variability, my spread, is also going to be affected by multiplying or dividing by that constant C. Once you guys get this copied down, I want you to take a few minutes to do the check your understanding that's down below. While you guys are working on this, I'm going to pass back your tests so that you can look over those, and that way if you have any questions, you can ask me. The grade that went into Skyward is circled in blue. What's in orange is your raw score before the curve, but it does not show you your percentage. In about 6 minutes, we'll go over the answers for the check your understanding. So please make sure that you take a little bit of time to do that as well. About 6 minutes is when we'll go over there. On the third question, if you see an orange okay written there, you got credit for that. I originally had a mistake on my answer key, and so I went back and regraded those with the corrected answer. So if you see an okay, you got points.
Is 5 an odd number? Oh, okay. Yeah, so we're looking for two groups. I don't know if I've been recording audio this whole time. That is a problem. I'll check that before I post it. My apologies, guys. Okay. All right, let's go through this. Come on. Love it when my stuff doesn't work right. All right. So consider the graph of the probability distribution of X and a separate graph of the probability distribution of Y. So here's what we know. X is the number of billionaires in a randomly selected state. This is the number of billionaires, and this is the probability of having that many billionaires in that state. Y would be the money received by a state if they pass this law, having each billionaire pay $1 million to their state. What do you think this distribution would look like? Like, let's just look at X. Look at these probabilities here. Does this look like it would be pretty symmetric, or does it look like it would be skewed? Skewed. Where would the tail fall? Is the tail more on the low side or more on the high side? There's more of a tail over here? No, it looks like this is where most of the data is, right? So where's our tail? Tail would be off to the right. So we would say that this is skewed to the right. Both X and Y would be skewed to the right. Y would be skewed to the right because we'd be having them all pay $1 million. So I would take the number of billionaires in the state and look at it that way. What would the mean of Y be? Is this a situation where I'm adding or multiplying? Multiplying. If you have no billionaires in the state, you're not going to get $1 million. If you have 1 billionaire in the state, you're going to get $1 million. If you have 2 billionaires, you would get 2 billion. So this is a situation where we would be multiplying. What am I going to multiply? If I don't want to find the new number and then multiply all of those and add them all up, what's the shortcut that we just talked about? Yes, I'm going to take the original mean and multiply it by 1 million. So 12,680,000. What about our standard deviation? What would we do for the standard deviation here? Multiply it by 1 million. So 29,020,000. What does that mean? Explain to me what this is representing. Yes. The amount of money received by a randomly selected state typically varies by about 29.02 million from the mean of 12.68 million. How does what we just did in number 2 and number 3 change down here in number 4? Now we're subtracting, yes. Shape would stay the same. Mean would go down by 500,000. Standard deviation would stay the same as before. There we go. Guys, I need your tests back before you leave the room. Please put them score side down in the test basket before you leave. Please put them score side down in the test basket before you leave.